Good morning, students. Today we are going to discuss the second application of dimension, that is to derive the relationship between various physical quantities. That means how to derive an expression. Between various physical quantities. So I will discuss that with a question, then only you will understand clearly. So just go through the question. The time period of a simple pendulum. You know what is simple pendulum? There is a bob which is attached to a string and it oscillates to and fro. That is called simple pendulum. So the time period of oscillation of a simple pendulum depend upon the mass, depend upon the length of the string and acceleration due to gravity. Derive an expression for the time period. So they will ask the question like this, derive an expression. So let us first analyze which all are the factors given in the question. Mass is given m, length is given L and acceleration due to gravity G. So these are the three quantities given. But we don't know how these quantities are multiplied or divided. And so what we are doing is, we will just write time period T is equal to some constant K. I don't know what is that constant. So I'll just put some constant K into mass raised to A, length raised to B and acceleration due to gravity raised to C. I don't know what are the powers to which these quantities are raised. What are the exponent values? That I don't know. That is why I just put M, L and G within the powers A, B and C respectively. And our aim is to find the powers A, B and C. Okay, let us see. What is the dimension of time period? T itself. I will write here M0, L0, T1. This is same as T. So I wrote the dimension of time period like this. Constant does not have a dimension. Now what is dimension of mass? Capital M. So I write M raised to A. What is the dimension of length? Capital L. So I write L raised to B. And the third one is acceleration due to gravity, which is same as acceleration. So dimension of acceleration is LT minus 2 raised to C. Now equating the dimensions, that is the next step. Equating the dimensions on both sides. Okay, so here what in the left side, what is the dimension of M? 0. In the right side, what is the dimension of M? What is the power of M? A. So in the left side, power of M is 0 and right side power of M is A. So I got the answer A equal to 0. Now compare the power on the left side for length. For length, what is the power? 0. What is the power on the right side? B plus C. B plus C. Now from here I can write B is equal to minus C. Now we compare the power of time period. Power of time period on LHS is 1 and power of time period on RHS is minus 2C. So from here C is equal to minus 1 by 2. So I got C is equal to minus 1 by 2. And look at the second equation, B is equal to minus C. Then what is B? B is equal to minus of minus 1 by 2, which is plus 1 by 2. Therefore, I got now the expression for the power of A as 0, power for B as plus 1 by 2 and power for C as minus 1 by 2. So you got these three things. You can substitute these quantities in the above equation, that is equation number 1. When you put it in this equation, how will the answer be? So I'll write T is equal to K into M raised to 0, L raised to 1 by 2, G raised to minus 1 by 2. This can be written as K, M raised to 0, any number raised to 0 is 1. So I am not writing it now. I just write L raised to 1 by 2, G raised to minus 1 by 2, I put it in the denominator. So I got G raised to 1 by 2. This can be rewritten as L by G whole raised to 1 by 2. And anything raised to 1 by 2 means root, square root. Therefore, T is equal to K into root of L by G. So this is the expression for the time period. So this is how we will derive the expression for any physical quantity. First we will write it in powers and we put the dimension, and then we will equate the powers on both sides, get the values of A, B and C, putting in the first equation. That's the procedure. The same way we can do any sort of equation. And this value of K will not be obtained using dimension. By another method, they will tell what is the value of K, and then when we put the value of K, you will be getting a real equation. So in dimensional analysis, using dimensional analysis, we will only get equation up to this. So let us see one more question. The centripetal force of a planet around the sun may depend upon the mass, depend upon the velocity and radius of the circular path. So obtain the expression for the centripetal force. So here they ask us the expression for the centripetal force. So I will write F for force, some constant K. Which are the quantities given? Mass is given, velocity is given, radius is given. So M raised to A, V raised to B, R raised to C. Let this be our first equation. Now write the dimensions. That's the next step. Write the dimensions of force. M L T minus 2. That is the force. M1 L1 T minus 2. I write it like that for convenience. K into dimension of mass is M. So M raised to A. Dimension of velocity LT minus 1 raised to B. And radius is length only. So L raised to C. So these are the three things I got. Now equating the dimensions. Equating the powers. Equating the powers. So what is the power of M? In the LHS, power of M is 1, and in the RHS, power of M is A. So I got the answer, A is equal to 1. Now compare the powers of L on both sides. In the LHS, the power of L is 1. In the RHS, the power of L is B plus C. Now you compare the power of time. In the LHS it is minus 2. In the RHS it is minus B. So minus 2 is equal to minus B. From there I will get B is equal to 2. Now putting the value of B in the above equation. So 1 is equal to 2 plus C. So from here what is C? 1 minus 2, which is minus 1. So I got C is equal to minus 1. Now look at the values. I got the value A equal to 1, B equal to 2, C equal to minus 1. Now I put the values of A, B and C in equation 1. So F is equal to K into M raised to 1, B raised to 2, C raised to minus 1, not C, R raised to minus 1. So F is equal to K M V square, R raised to minus 1 can be written as R in the denominator. So our final answer will be F is equal to K into mv square by R. Okay, this is the expression for the centripetal force. And again, as I told, the value of K can be obtained only by other methods. So dimensionally this equation is correct. This is how we find the expression for the various physical quantities using dimension. So that's all for the applications of dimension. Thank you.